Welcome to the Pre-Calculus Notes video for Unit 1, Lesson 3, Inverse Functions. Today we will be connecting algebraic identities to the idea of inverse functions. We will examine how to identify functions and inverses of functions. We begin with the additive identity. It basically says if we take any number and we add or subtract 0, we end with exactly the number that we started with. So if I take x plus 0, I get x. Likewise, I could do x minus 0, which would still leave me with x. Next, there's the multiplicative identity. If we take any number and we multiply or divide by 1, we end with exactly the number that we started with. So if I do x times 1, I get x, or x divided by 1 also gives me x. Knowing that the additive identity is 0 means that if I can add and subtract the same number, it will equal 0, keeping the identity. Thus, addition and subtraction are inverse operations. So if I do x plus 5 minus 5, that's the same as x plus 0, which equals x. Knowing that the multiplicative identity is 1 means that if I can multiply and divide by the same number, special note, not 0, 0 does not apply, it will equal 1, keeping the identity. Thus, multiplication and division are inverse operations, except for when using 0. One undoes the other. So if I do x times 3 and I divide by 3, that is the same as x divided by 1, which gives me x. So this basically just is a way for us to consider that addition and subtraction are inverse operations, multiplication and division are inverse operations. So we can extend beyond the basic 4 operations of addition, subtraction, multiplication, and division. Any function which will undo another, which means that if we apply both, we get back what we started with, are considered inverse functions. So any two functions where one undoes the other. Now we want to be able to identify what it means or what it looks like when we have an inverse function. So what we're going to be doing is we're going to be comparing the inputs of the first function with the outputs of the second. We're going to look at this in two different ways. We're going to look at a function represented by a table, and we're going to look at some graphs. So here we have two tables. You'll notice one says x f of x, our original function, and then x f inverse of x. Notice we use this f to the negative first to indicate inverse. And what we're going to do is we're going to notice how these two tables compare to each other. So let's come up with a very simple function. So 1, 2, 3, 4, 5 is going to map to 3, 8, 1, 7, 2. So here's my function. I know that if I input 1, I get an output of 3. So when I look at the inverse of that, it means that it should work in the opposite direction. So I started with 1, I got an output of 3. So if I input 3 into the inverse function, I should get my output of 1 back. If I input 2, I get 8. So if I input 8 into my inverse, I should get my output of 2. 3 gave me 1, which means 1 will give me 3. 4 gave me 7, so 7 should give me 4. And inputting 5 gives me 2, so inputting 2 should give me 5. So in essence, all we did was swap our x and y values. Now, if we're looking at a graph, we can use this exact same strategy, knowing that the x values of the original function become the y values of my inverse function. So we're going to do two very quick examples of how to do this. So I'm going to start looking at some points. I'm going to start at the far left. Why not? This is the point -2, 3. If I switch those x and y values, I end up with the point 3, -2. And I plot that point. Here is the point -1, 0, which means that will leave me with point 0, -1, which I'm going to draw a little bit bigger since the point already exists. 0, -1, which is this point here, gives me the point -1, 0, which is right there. This is point 1, 0, which gives me 0, 1. And this is 2, 3, which will give me 3, 2. So if I connect these, what I end up with is a graph that looks very similar to the original, but it's kind of been turned on its side. Now, we're going to do the exact same thing for the second one. We're going to pick some points that we can easily identify. So we'll do this one, this one, this one, that one, and that one. All right, so we have -4, 0, so we're going to plot 0, -4. This is the point -3, -1, so we're going to do -1, -3. This is -2, 0, so 0, -2. This is -1, 3, so 3, -1. And this is 3, 1, so we do 1, 3, giving us a graph which looks like this. Now, the really big thing to understand from this is it's all well and good to say I can switch the x and the y values and I can plot them. But even more importantly is we notice that these two seem to have a very distinct relationship. So what I'm going to do is I'm going to draw in the linear identity function y equals x. And what we're going to notice is that these functions, the original function and its inverse, are going to be reflections over that identity function y equals x. So if we were given both a function and its inverse, or a graph that we believe to be its inverse, we could look at individual points, or we could look at it as a whole and try and determine is it or does it represent a reflection over the line y equals x. The last piece that we want to examine today is looking at a graph to determine if it is a function. Now, this should be familiar to you. We know that if we're talking about a relation and we want to say that it's a function, that means that we aren't reusing any x values. Each x value is only used once. So one of the ways that we do is to use what is known as the vertical line test. So the vertical line test says that if it's possible to draw a vertical line that crosses the graph in more than one point, then the graph is not a function. So in essence, we're just looking at a graph and saying, do we think it's possible to draw a vertical line that's going to hit the graph in more than one place? For my first function, it's absolute value. There do not seem to be any repeated x values, so we're going to say that this is a function. Here is my second graph. You should be able to see very clearly, even if I just look at this vertical line here. It crosses 1, 2, 3, 4, 5, 6 times. So this is not a function. If I look at my third example, again, I don't have to look any further than the y-axis. This is not a function. And my fourth graph, I'm looking at my x values. There do not seem to be any repeated x values. So we are going to say that this is a function. So what we're going to do is we're going to use that information, which should be familiar to you already, and what we were just talking about with regard to inverses. Now, if we know that an inverse basically swaps the x and y values, then we can use the exact same test to determine if a function's inverse is a function. But instead of being vertical, which uses x values, we're going to make the line horizontal, which is y values. So if we look at the 4 examples we have here, we're going to try what we call the horizontal line test. Now, all 4 of these graphs are functions. You can quickly do a scan and say, nope, I wouldn't be able to draw a vertical line that crosses multiple points. So we know that these are functions, but now we're going to use the horizontal line test to determine if its inverse would also be a function. Looking at my first graph, it does not appear that there are any y values that are used more than once. I wouldn't be able to draw a horizontal line that crosses this curve more than once. So we are going to say the inverse is a function. Here is my second graph. Now I can draw this line right here, which is going to cross twice. So the inverse of this one is not a function. Here is my third, a beautiful absolute value graph. If I were to draw this line here, oh, well, almost. If I were to draw that line here, again, you're going to see that it intersects in more than one spot. So the inverse is not a function. And my last one here is an exponential. And it looks like it comes pretty close here. But we also know that exponential functions have a horizontal asymptote where it is approaching that number but never actually gets there. So be very careful about these horizontal asymptotes because it'll look like you wouldn't be able, or that the horizontal line test would say that the inverse is not a function when it actually is. So the inverse of this is a function. So we've determined whether a graph is a function, and we can look at that same graph and use the horizontal line test to determine if the inverse is a function. So the question is, why do we care? Here's why. If the inverse of a function is also a function, then we know that both functions are one-to-one. So if a function and its inverse are both functions, then they are 1-1-1. And that gives us a lot more information about what the actual function does and some other properties. So once again, if you go all the way down here to the bottom, there is a space for you to do your notes summary. So you can write down any important ideas, things that you want to make sure that you remember, or any questions that you have that you want to ask the next time you're in class.